And he alluded to our friend Tony Dubiel. He is a product solution architect here at Red Hat. And for North American Public Sector, NAPS. He's an Air Force veteran with over 25 years of experience in telecommunications and network automation. Before joining Red Hat, Tony worked at Cisco, WWT, and Northrop Grumman. And a fun fact about him is that he hosts an Ansible for Networking online meetup. So check him out on LinkedIn. I think you meet, what, every 2 weeks? Every 2 weeks. It is very informative. A lot of folks are very engaged with this, so we want to hear about Ansible best practices for automating firewalls with the focus and demo. He's going to do a demo for Palo Alto. Tony, everybody.
Thank you, Angela. And thanks to Sebastian for setting the stage for this demo that we'll go through. But before we go into the demo, I just want to go over a few things just to level set. So we'll talk a little bit about some of the network security challenges. So a lot of this will be through the lens of networking and firewalls. And we'll take a look at some firewall use cases in terms of automation. How many people in the room have experience with firewalls? Okay. And then I'm assuming many of you have experience with Ansible. So I promise by the end of this demo, you will have some level set of both of those if you're new to these technologies. One thing we will drill into is the PAN-OS certified collection. And Sebastian had mentioned the value of our certified collection. So we'll double click there and I'll explain to you how the modules were vetted through additional rigor, but also how you can implement them and how they would map to common tasks that you would typically configure in firewalls. In this case, PAN-OS firewalls, but a lot of this that we talk about would be very similar to other vendors as well. This is a multi-vendor paradigm that we'll talk about. And then ultimately we'll end with the demo. And the demo will show you how simple it is to orchestrate a workflow to automate many of the tasks that you would use to configure a Palo Alto firewall in this example. So some of the network security challenges. One of the challenges here, and this is kind of a complex diagram, but this is depicting zero trust security for network access. And when you configure network segmentation today, it's complicated for firewalls because now they must fit into this broader architecture for ZTNA, which means that they have to interact with other types of devices. So routers and switches, and in some cases load balancers and the like. And on top of that, enterprise networks are becoming more complicated in access to constructs like cloud. In this particular example, we're looking at hybrid cloud. And in the diagram here, you can see that there's two ways of accessing the hybrid cloud. One is remote access through a VPN, which would require participation from the firewall, along with routers and other infrastructure. And then we have SD-WAN, which is a popular way of providing an on-ramp to your clients to access servers from the edge. So having said that, this means that there's multiple devices, and we tend to have various operations tools that look at the availability and in some cases provide discovery and network mapping and the like. And all of that typically maps to policy engines. So if we look at identity policy, sometimes that would require more of a proprietary viewpoint, which is complicated because the end goal here is to provide automated remediations and to enable that across multi-vendors. Ansible is uniquely positioned to provide us with a multi-vendor way to automate the provisioning of these various devices and to orchestrate that through workflows and to provide all the other guardrails that are needed to be able to do this successfully in production at scale. So kind of zeroing in again on the ZTNA, and if you look at requirements on what that path would take, that journey to optimizing ZTNA, then Ansible is paramount because it provides us with a way to, again, provide that type of segmentation in a complex infrastructure at scale. And newer technology within Ansible that we've talked about a little bit, one of those being event-driven Ansible or event-driven automation, provides us the mechanisms to respond to alerts and triggers. And then ultimately, we need to be able to provide automated remediations. So you'll see that not in this demo, but after lunch, you'll see this orchestrated through Splunk. But there's also other alternatives through EDA that I'll touch on a bit as well. And then another emerging technology is DevOps best practices and the ability to provide infrastructure as code. So Ansible is infrastructure as code, and allows us to integrate into CI/CD tools, continuous integration, continuous delivery, and GitOps to be able to integrate using webhooks and triggers and some other things that we'll talk a little bit more about later to allow us to enable our automation to go to that next level of end-to-end automation in terms of pipelines. So some of the use cases for firewalls, and again, we'll map this to where Ansible automation adds value and benefits. A basic use case that many of you are probably very familiar with is just a north-south firewall. So here, the networks tend to be fairly simple, fairly static in terms of accessing the firewall. And effectively, the firewall is commissioning and decommissioning firewall rules to allow access to those application services. So where Ansible provides value here is, even though the infrastructure is simple, we may have a lot of changes made to the firewall rules, especially decommissioning. A lot of times those entries become stale, and then Ansible provides a way of easily being able to maintain the hygiene of your rules in that context. Now, moving into more complex use cases, the data center tends to add more complexity because oftentimes now we're dealing with east-west firewalls. So this means that we're looking at server-to-server traffic or traffic between tiers, application tiers. And oftentimes this is within a data center, but it could be between multiple data centers. And this adds complexity because in the switching infrastructures, we may have native load balancing technologies, like on the slide it shows the policy-based redirect, or it could be external load balancing. And the network infrastructure needs to make traffic decisions on how to route traffic in and out of these firewalls. And the firewalls themselves could be physical, they could be virtual. So with Palo Alto, PanOS as an example, the VM series are virtualized firewalls as VMs. And we need a way to be able to automate the policy of the infrastructure, the network fabric, as well as the rule sets, the security rules in the firewalls. So we can bring that together. And effectively, like Sebastian said, we can glue that, stitch that together using Ansible and orchestrating workflows between those devices. Moving into public cloud, in this example, it's AWS, but it could certainly be any of the public cloud providers. In this configuration, we have virtualized PAN firewalls, the VM series, and we have Panorama, which is the GUI management platform for the PAN firewalls. Now, in this case, it can manage the firewalls for us from the GUI, but also can provide log aggregation. So in the demo after lunch, you'll see Splunk, but it could be Panorama for the log aggregation. Now, why would we consider using Ansible on top of this existing management system? What this would do would help us prevent or avoid the phenomenon of death by 1,000 clicks, right? Because when we use these GUIs at scale, they tend to become very difficult to apply policy across multiple devices. So with Ansible, we can simplify that by creating workflows and effectively using the collection of modules against the Panorama. So the way that the modules work, it does work directly to the PanOS firewalls, as well as to the Panorama has an API that's also included in that wrapper of the collection of modules that we'll talk about. This is SD-WAN. So SD-WAN can be delivered not just with routers. If you're familiar with like Cisco, Meraki, or Viptela, or any of the SD-WANs, typically they're built around routers. But you can also build SD-WAN around firewalls. And that's what this is. So this is using the PanOS firewalls, as well as the Panorama for the management again. So here it's even more complex because we're actually traffic engineering, based off of the firewalls. And we're also providing that segmentation from the security rules and policies as well. So we can deliver through the collection. Ansible can manage that in an automated way as well. So again, it will allow us to scale. Prisma is a bit different. This is an emerging architecture based off of SASE. So that is Secure Access Service Edge. And most of these solutions are SD-WAN as a service, which means that it's managed through the cloud. So it's a cloud managed version of their SD-WAN. And this would be akin to like Cisco Meraki if you're more familiar with that. But in these solutions, everything is delivered from the cloud. And again, we can integrate into this architecture, not using the PAN-OS because this is not based off of PAN-OS. Prisma has its own collection. So there is a collection for Ansible to manage effectively, again, the GUI of the Prisma using Ansible. So those are the use cases. Now I want to drill down a little bit into the certified collection. If you look to the right, this is the PAN-OS certified collection. And as Sebastian mentioned earlier, there's a lot of value in the certified collections. And before I go into the details of PAN-OS, just high level, some of the benefits is it provides consistency. So I mentioned earlier, all those various devices that the firewalls have to work alongside in ZTNA, many of them have collections as well. And what you'll find is consistency and synergies in the sense that if you're configuring a router or a switch with ACLs, access control lists, versus a firewall with security policies, you're going to see that the modules themselves, in particular the resource modules, will look very much the same, even load balancers to some extent. So once you have the skill sets to work with the modules and the collections, a lot of that's going to transfer over across multiple vendors, but also across multiple devices. So there's a lot of value in that low barrier to entry. Once you understand Ansible, you can apply it across many devices, and there's not all these various, nuances in that regard. So with PAN-OS, one of the benefits that once we implement the modules and the collections is, some of the things we talked about earlier, avoiding human error, right? Because we remove the command line in the GUI, also reducing risk in terms of security and providing a mechanism to automate compliance and to allow us to respond to security instances, events much faster. And then ultimately, it should take a lot off the plate of the operators so that they can focus on high value tasks outside of the mundane tasks that we can easily automate right away with very quick wins in that regard. So in this particular collection, we can do much of the tasks that typically we would perform on a firewall manually. So some of those are, like I mentioned, that happens a lot: commissioning, decommissioning firewall rules, onboarding servers. We're actually trying to figure out application dependency mapping and the like to make sure that we have the proper ports open. And then optimizing our rule sets by using objects. So that way we can, aggregate together, various policies that make sense. And then all of the other operational tool sets that we use in the firewalls, like the logging and the lifecycle management and updates of the firewalls themselves. Another aspect, and this slide seems like it kind of got a little bit messed up, is I mentioned the event-driven Ansible, and we're going to look at Splunk actually creating triggers because of events, and then Ansible would provide remediations by making changes to the rule sets. We have what we call a EDA plugin that's a part of a very special plugin that's provided directly from, in this case, Palo Alto, so that we can talk directly to EDA. So effectively what that means is that if we send logging information from a PAN-OS firewall or Panorama directly into EDA, we can create an automated remediation because that trigger would create what we call an action to respond to a rule set. So that'll make a little bit more sense as we move a little bit further into this. But the idea here is that we do have a plugin, and that's what this link is. So if you're interested in seeing EDA in action with PAN-OS firewalls, then you'll have that link as part of this deck to that GitHub repository. So now we'll go into the demo. This is the link to the demo. So if you like any of the playbooks that are used under the hood, you can go to this particular GitHub and you can use them for your own purposes, or if you just want to take a look at them later as a reference. So I'll go ahead and start this. Okay, it's actually moving around. So this is a unconfigured, non-configured firewall. So before we bootstrap the firewall, none of the interfaces work. None of the other constructs are there, like zones. Typically, you'll divide the firewall in like an untrusted and trusted zone. We'll build those through automation. And then we have no policies at this point other than the default policies to allow all outbound traffic and to deny all inbound traffic. So we're going to build rule sets to allow web traffic, because we'll use that later in subsequent demos to show more of the advanced capabilities. And at this point, there is no access to this web page. So we'll enable that. Here what we see is I'm launching the workflow. And I mentioned a workflow earlier because this enables us to orchestrate multiple playbooks together. So this is the stitching together of playbooks. And what we're able to do here in a workflow is provide conditions. So on success, you can see the green lines would map to subsequent stages that are job templates that we would perform as one playbook succeeds, then we would launch the next playbook. But if they were to fail, in this case, I've created approval stages so that we can perform troubleshooting. And then when we feel confident that we've resolved the issue, we can move forward and our workflow would reconvene and move on to the next step. So what we've built so far, and we'll drill into this, the actual output, is the PAN initial. This is the bootstrapping of the firewall. So configuring those interfaces, configuring zones, DHCP, much of the configurations that you would configure, in some cases, one and done, just the upfront day zero types of configurations. And then we move into like optimizing our configurations into objects. So instead of building, several security rules, we want to organize them into objects. We're going to build a web object that we'll use for our particular demo. And then PAN policies would include the security rules as well as NAT policies. So NAT would allow us to host, in this case, a web service using a public IP address, but really we have, a private IP address that's a part of the trusted zone on the inside, and providing access to that, which would also require us to provide some level of routing. In this case, we'll use static routing to route between the interfaces to enable NAT. And then ultimately, you'll see that as these succeed, these are Slack notifications. So Slack is just an example of a chat ops tool, but this could be any messaging tool that has an API. Ansible has the ability to send notifications with important information, in this case, the job numbers. So at this point, we can see we do have interfaces. We've implemented them using DHCP, so AWS, in this case, has provided us with these private IP addresses, and they're enabled. And we have two zones. We have the untrust zone on the front end, and then we have the web zone that connects to a server where we'll host a web service, and we'll use that for this demo, but also the demo after lunch where it becomes more advanced. These are the routing rules I mentioned for NAT. We have to understand like what interfaces are on which zones, so we need to be able to route between them. We could certainly turn on dynamic routing in a more complex configuration, but here we're just using static routing. And then now we have some security policies. So the one that's important for us in particular is the web browsing. So we're going to allow really any source to connect to that web server, but at some point we're going to limit that because we may have some malicious activity in the subsequent demo. And then from a NATing perspective, we have to provide access through NAT for HTTP to enable us to connect to that server that's on the inside of the firewall. So we've enabled NAT there. So at this point, when I reload, it's configured for policy so we can access this web server. And this is kind of where we'll start in the next demo after lunch. And you can see here, this is just tracking, it's monitoring the connection. So this is a connection that I made when I recorded this video for port 80. And we have access to this, from Ansible if we want to glean any of the operational state from the firewall, which includes the connections that you see here. So at this point, it's completed. And what I wanted to do is quickly drill down into some of the constructs that we used under the hood. So this is a basic playbook. So if you're familiar with playbooks, one thing that they do at a minimum is they provide you with the host or the groups that you want to point to in your inventory. And it also includes tasks. So in this case, you can see that I have tasks, but really what I'm doing is I'm including roles. So a role is a purpose-built playbook. And the value of a role, which are typically packaged into collections, is that we can repurpose them and use them across teams with other playbooks. We can call them from other playbooks, and we can keep them very cohesive, very modular and focused on a particular use case. So purpose-built playbook and then we'll create variables to define how we want to use that role. And when we actually execute it through a playbook. Another mechanism that we're using here are tags. And Sebastian mentioned this earlier when he was talking about tags. This allows us to call a particular task in a playbook. So here I'm pointing to a tag of interfaces, and how that translates from a playbook to the AAP controller, the automation controller. If you look at the GUI configuration in the middle here, you can see that we are also pointing to the interfaces tag. So a job template, and that's what we're looking at here in the middle of the screen, a job template is one of those stages that we saw in the workflow earlier. So this was the first job template, pan initial, and it's calling this playbook, and the playbook is pan_config.yaml, and it's pointing to the tag of interfaces, so it's only going to include the role for initial setup, and then commit is so we can commit that change to the firewall. So we save our configuration changes after we complete each one of those roles. So moving into the role, and I know this one's probably hard to see, but if you look towards the bottom left, you can see DHCP interfaces. And primarily what we're doing here in the role is that we're effectively defining parameters, right? And we're using variable placeholders. And what we want to do is we want to iterate through them. So you can see that we're using other constructs like loops. And how we define the variables is in a configuration file. So in this case, we're using host vars. And the name of that file is panos-firewall. That's the actual name of the firewall. That's how host vars work. And that's where we're defining those parameters. So if you look to the right-hand corner at the bottom, we have interfaces. So we're building two interfaces, Ethernet 1/1 and 1/2. 1/2 is the untrust interface, so it maps to the untrust zone. And then we have Ethernet 1/1 that maps to the web zone, where we have our server that we're providing access to that web port, as an example. So that's an example of a role. This is the output when running this particular playbook from the automation controller. It looks very similar to the standard output if you're running Ansible Core Engine on your laptop, as an example. Two things to keep in mind. When you see the yellow changed, that means that we actually made a configuration change. So that configuration did not exist on the firewall, like the interface configuration and the like. The green ones that are okay, that means that that configuration already existed and there's no need to change it. So Ansible and the modules are idempotent. So that way, there's no need to make a change. It's effectively providing a merge, right? So it only changes what it needs in that configuration, but there's other states that we can use. And we'll look at the state of gather here in a moment too, because it's a very important state for you to be able to glean existing configurations out of devices and create automation from them. So in this role, just to pick on another one, is the security rules. And with the security rules, we're setting the parameters for the security policy, in this case for our web connectivity. So what I wanted to do was just kind of walk through the taxonomy of this again. So this was the PAN policies job template that we saw in the workflow when we orchestrated the workflow. And what this is doing is it's pointing to the job tag of policies, and then policies points to the security rules, and then we'll iterate through these variables. So in this case, and what's important to us, and important for the next demo after lunch, are the security rules for web browsing. And you can see here that we're allowing really everything, every source address at this point, but we can always change that dynamically, and that's important to note. And it's a value of automation, being able to make these changes on the fly. And then this is the output, and what's important here is that we have the security rule, web, with the source and the service defined from those variables, but also the web object that we defined as a NAT rule. Because without that, we wouldn't be able to connect to that internal server that has a private IP address. The gather state that we mentioned earlier allows us to ingest an existing configuration. So in this case, we're pulling in the security rules and the NAT rules. And this is important because we can use this to manage configuration drift. Because perhaps someone comes in out of band outside of the automation and makes a change. We can pull in a configuration at any time and then do a diff check to see if it had changed. And if it has, we could overwrite that configuration, or perhaps it was meant to be, it was some sort of troubleshooting or responding to an incident, and then we can change our automation on the front end, effectively changing our single source of truth on the front end. And then lastly, we have these PAN-OS facts, and they're very important because I mentioned that it's very easy to implement compliance. So when building compliance checks, oftentimes we want to pull in the entire configuration of the device, in this case, in structured data, and we can quickly point to checks for compliance like the version of the software. In this case, it's 10.2.2, and that could be pass or fail criteria for a compliance check. So here we're towards the end of the session, and I wanted to point out if you want to go through and provide a similar automation workflow, you can go to the self-service lab through this link and through this QR code, and it'll allow you to access a PanOS firewall that's running in the cloud, and you can go through and configure the actual workflow in the automation controller, and all of those playbooks are also available from a public repository too. So if any of that stuff is applicable or relevant to your environment, feel free to use those playbooks and to try them out in this environment that we call Instruct. And here's just some more reference material. So I kind of ended, I guess, a little bit quicker. So we do have some time for questions. But again, I know I'm standing between you and your lunch.
Tony,
so I'll definitely be.
Tony, can you hear me? Yeah, I'm going to ask a couple questions from our online audience. Does Ansible integrate with Cisco ACI? And does it have the ability to query and configure ACI using APIs?
Yes. So it's kind of two different work streams. There is a collection to provision just about everything that you can configure in current ACI fabric. But where it's a bit complicated is ACI has this architecture where there's the actual local fabric from a data center switching perspective. And then you have multi-site, which is a configuration where you're configuring ACI between multiple data centers. So that too has a collection, but typically that's implemented in the Nexus dashboard. So they have the Nexus orchestrator. So we have a collection, so it depends on what you're configuring. If it's either localized or if it's spanning across data centers, then you would choose either collection for the provisioning side of it. For operations, then that's where you can use other technologies like EDA to do some cool things, because ACI also has web sockets, which is similar to like web hooks. So there's a lot of cool things you can do by gleaning through REST APIs, like faults and health scores and things, to pull that in and use that for like operational state with ACI.
Okay, thanks. And similarly, somebody asked, can Ansible integrate with Cisco Panorama?
I'm not sure what Cisco Panorama is. There's the Palo Alto Panorama GUI. I'm not sure. I'll have to look into that one. If that's something like brand new, I'm not sure exactly what that is.
And then how can we encourage other teams to consider using Ansible, especially if they're siloed? We use it extensively for one team, but would like to extend it to network security and operations.
I think if you look at some of the use cases, they span across domains anyway. So like compliance as an example. Sometimes there's aspects of compliance that are very unique to the type of devices. So that could be, very much, something that would only make sense to a particular team. However, things like NTP servers or various operational tools or telemetry might be very similar across all those devices. So you could orchestrate a workflow that does checks against very generic things like that, aspects of compliance that would work across all of those. So that way, they're using different modules and different collections, but through Ansible and orchestrating a workflow, then that would allow them to stitch those together or to glue those together, like Sebastian mentioned in the previous session.
And one more question. How can we use Ansible to automate for zero-hit rules, dormant rules, and clean up zero-hit rules in firewall?
Yeah, so that involves like a lot more logic and data manipulation. So there's various techniques where we're either gathering facts from devices, or now with EDA, we can receive streaming telemetry. So a lot of that would be different depending on how we want, which technology to use to implement it. But I think at the end of the day, it's all structured data. So that's where, we can provide, and it's also like a good segue like into consulting services. There's a lot of data manipulation that we can provide on top of just these baseline, vanilla types of workflows, where we can drill into that structured data a bit more and then provide more reporting and, other aspects of like multi-layered orchestration through multiple workflows.
All right, we have like 1 more minute for any questions in the room. Anybody have any questions?
Sure.
Yeah, hold on. Hold on, let me.
Oh, she's got the mic for you.
So I'm new to automation. I'm a network engineer.
Okay.
And you said something about the playbook. Now I have an issue where I have like 120 routers to configure. Now, do you create? I know the playbook goes and pulls the config. You showed another file on the right.
Mm-hmm.
Now, for 120, do you create 120 of those so it goes and pulls I forgot what it's called, right? Does it go in? So the playbook pulls like the IP where you have the IPs.
Yes.
Right.
So that's a part of the inventory.
Yes. Now, does it go in and do I need to create 120 of those 128 different IPs, or I can just put it in just one file and it goes and pulls the IPs and does run the configuration against those IPs?
Yeah, you could have a static inventory where you create groups, because it's always good to create groups because you may have parent-child relationships where some devices are in groups but others aren't. So you can define like where these devices are accessible through groups, and that could be provided either as an INI file or a YAML file. But for like a dynamically changing infrastructure, if the IPs are going to change a lot, sometimes it makes more sense to implement a dynamic inventory. So there, your source of truth for the actual IPs could be from like an IPAM, like an info blocks or similar, right? Where it always knows the state of what device is mapped to an IP. And then you can pull them in through structured data and then create updates to your inventory prior to running your playbooks. And playbooks are implemented through job templates in the automation controller. But sources of inventories can be pulled in from repositories or databases, or really there's so many different sources. But effectively, at the end of the day, it could be dynamic if it's going to change often. Is that your challenge in particular?
So we're replacing 128 routers, right? So different interfaces, right? Different IPs on those interfaces.
So
right?
for like that type of thing, that would be a part of the not so much accessing the device. That's inventories are your targets for automation. But if you have like interface configurations in their IPs, then what that would be considered is a good candidate to define them in host variables, because those IPs are very specific to that one particular device. So what happens is when the way that it works in practice is that you name the device, the host name, and then in the inventory, that host name, you can create a host vars file in a host vars folder with that host name, and Ansible will check that file and iterate through that configuration. Okay. So that way you would have like just anything that's specific to those devices. If you had 100 and something, you might have 100 and something specific, entries for that. But the things that are common across those devices, you could define into group variables. Okay. And those variables would only exist, at a higher level.
Thank you.
You're welcome.
Thank you, Tony. Please give it up.
Thank you.